So I'm either going to do problem 1 or problem 2. I don't know why I put both of these on here. They're really the exact same kind of thing. So I'll let you guys pick. Do you want to do 1 or 2? The same problem. Different numbers in them. All right, we'll do number 1. So we're going to find the inverse. And we did this last time was inverses. But today we're going to go a step further and state the domain and range of both the original problem and the inverse. And they're just going to swap. That's all it is. You make a face. You're going to be okay. They're just going to flip flop. All right, so to do an inverse, you switch X and Y. And so what I always say is it would sure help an awful lot if there was a Y in the problem. So I would scribble out f of X, call it Y, and then we're going to switch X and Y. Everything else stays put. The fraction bar, the 2, the -3, the equal sign. Don't change any of that. You're just switching the X and the Y. All right, then what? Now you have to do some algebra until you get Y by itself. So what are we going to do next? Good, we're going to move that to the other side by multiplying, but basically it just moves over. So you're going to have y minus 3 times x equals 2. Algebra is just moving things. We just moved it over there. And then we're going to divide by x. So divide both sides by x. Again, you're just moving that to the other side. So you get y minus 3 equals 2 divided by x. And then your last step is what? Yeah, add 3. And if you write y equals full credit, okay, I'm not going to take off points, but I will be happier if you put inverse notation to show me that you know what that means. So 2 over x plus 3. So we're going to go back and do the domain and range of this original equation, and then the domain and range of our inverse. Once you do the first one, the second one, you just swap them. That's all that it is. And so on like a test situation, if these were wrong, I would take off. But down here, if you just flip flop what you have, then you get credit for these ones. Get what I'm saying? Like you're showing me that you understand they switch. So domain, who's your troublemaker on this one? 3. Kick out 3. And so here, we'll go ahead and do that now. If that's the domain of this function, then that's going to be the range for the inverse. You literally just switch them. That's like the goal of the lesson is for you to understand you're switching the input and the output. Now here, I would think of this visually, and I'll just grab a sticky note and draw it off to the side and just show you what it would look like. You would have that vertical asymptote at 3. You're all with me here? And then it would do something like this. Ooh, I ran into it. That's bad. Don't do that. Okay. But what is your Y value that is not invited to the range party? 0. Because this did not move up or down. Like, do you get what I'm saying? If this had like a +7 at the end, it would move up 7 and then it would be at 7. Is this landing? Making sense? Okay. But we didn't shift up or down, so it's still at 0. And so 0 is the number that we want to leave out of our range. So it's everything except 0. And if that's the range for this equation, or function, I should say, then that's the domain for the inverse function. So all you're doing is swapping them. That's it. So this is what we did last time. Find the inverse, and then we're going to graph both of them, and they're going to reflect over that line y equals x. So first, let's go ahead and scribble out f of x. We'll call it y, and we're going to switch x and y. Everything else stays where it is. So we got 3 steps. What are we going to do first? This is your unwinding. You're trying to unwind what's there. Yep, subtract 1. This is going to go nice and easy. I like it. Everyone's paying attention and we're good. All right. And then, not yet. Divide by 2. So we're dividing the 2 over. And then, yes, we will square root. Now, when you put a square root, you have to put the plus and minus. Now, I actually am going to write y instead of the inverse notation, and I'll explain why in just a minute. Okay, so let's go and graph our original function. What is it going to look like? Because it will not be a line. Yeah, parabola, because it's a squared. It moved up 1, so we're going to put a point at 0, 1. And then I'm going to make a little table. If you don't want to do that and you can do it in your head, that's totally fine. It's just I'm doing the problem in front of a whole group, and I just want to show you what's going on. So we have our point at 0, 0, 1. Let's pick some other numbers. What do you want to try and plug in? Yeah, 1 would be a good choice, and -1. Don't be complicated about it. Keep it simple, all right? So if we plug in 1 squared, 1 times 2, 2 plus 1, 3. So 1, 3. And because you know it's going to be a parabola, if you plug in -1, you are also going to get 3. You can go through plugging that in if you want, but it's going to be the buy one, get 1 point. So you get something that looks like this. Now, when you go to do the inverse, do you want to look at this to graph it? No, that would be a gigantic nope from me. Like, yeah, that's going to be a no from me. But the good news is you don't even need any of this because we're just going to take these points and do what? Flip them, all right? So instead of 0, 1, 1, 0. You're not negating them. Don't change the signs or anything. Just swap them around. Instead of 1, 3, 3, 1, and then you'd have 3, -1. So it is going to look like this. I'm bad at drawing them sideways though, so don't. Oh, if you plug in 0 for x, this whole part goes away. And then +1 is just 1. If you want to add that to the table, you can, like if visualizing it helps you. And then these reflect over y equals x, if you want to dot that in. It's not a requirement, but did you see it, the reflection there? Now, something should bother you about the inverse. This one right here, the inverse one that we did. What do you notice about that? Because you should go, hey, wait, hold on a second. Something is not right here. Well, it is sideways. It's not a what? Good. It's not a function. Why not? Yeah, it fails the vertical line test. There we go. I got it out of you. It fails the vertical line test. That's why I didn't write F inverse here, because it's not an inverse function. It's a graph, but it fails your vertical line test, so it's not a function. So what we have to do is cut it in half. I know this sounds like super violent. I'm going to use colors here. I know you guys back there like to color code things. If you want 2 different colors, you can do that. If not, it's not necessary. Just watch up here. I picked yellow and pink. I'm hoping that they'll show up on the projector here. So here's option 1. You can take the right half of your graph. We're chopping it in half. And so when you do your inverse, you'll only have this half of it. And so it'll be a function because you're only doing half at a time. So let's go ahead and write out our domain and range for the pink part that I highlight. Try to ignore the rest of this. Only look at the pink part. What is your domain for the original graph? Because it's not going to be all reals now. It's from where to where? 0 to infinity. Good. So your domain is 0 to infinity. So that's going to be the range for your inverse. Again, you're just swapping them. And then what's your range on the original function? Look where I'm pointing. We're trying to just look at the pink part. It's from where to where? 1 to infinity. Good. I don't really expect you to understand it on the first try. That's why we're going to do, I think I have 3 of them on here. By the time we get to the 3rd one, you're going to be okay. Now, do you see how the pink part is the right half of the graph? Do you see how we took the positive part? That means when you do your inverse, you do the positive square root. Now, if it's the positive one, we don't write a plus in front of it. Bless you. I mean, bless you. I guess you could. I wouldn't mark it wrong if you put a plus in front of that, but you don't have to. So you're choosing the positive half. You're cutting the graph in half. You're just doing half of it, right? I'm going to highlight the other half in yellow. We'll do what option 2 is. I don't know how well yellow is going to show up, but we'll see what we get here. The other part, the part that I didn't highlight pink. So now what is your domain for this original function? Watch me point to it. It would be from where to where. Try to just look at the left half of it, the yellow part. And only we would write, you're correct, we would just write, because you have to go left to right. So it's not 0 to negative infinity. Good, negative infinity to 0. Do you guys see that there for the yellow part? You got to look up here to see it, right? So it would be negative infinity to 0. And you can copy that over for the range. Again, you're just swapping them. And then what would be the range of the original function? Try to just look at this part up here. Where to where? 1 to infinity. Good. It's actually the same as the other one. And since for that one, we took the left side of the graph, whenever you do your square root, you just do the negative square root. So here's the whole long and short of it. You can only have half of the graph at a time. You have to cut it in half so that your inverse ends up being a function. Because otherwise, when you turn it on its side, it fails your vertical line test. Okay. And if you were like, hey, that's sort of shaky, go ahead and flip over. We're going to do a couple more. I'm not going to just do one and be like, all right, see ya. Okay. Now I'm going to do one the positive and one the negative. You can kind of pick, like, I only want the positive half or I only want the negative half. By the way, if I give you a choice, which side should you pick? Go positive. Negatives are the most commonly missed thing ever. But here in the notes, I'm going to do one of each. So this one, we're going to do the positive half, and this one, we're going to do the negative half, just so I can show you an example of both ways. So scribble out f of x, call it y. We're going to switch x and y. And so if we're doing the positive half of the graph, when we do our square root, we're only doing the positive square root. You don't put plus and minus. You're making a choice. I only want the positive part of it. So we would square root, just don't put a plus minus. And then what's your last step there? Yeah, add 5. And we can go ahead and put inverse notation because it will be a function. We restricted it so that we're only doing half of it at a time. Now, I like to do the graph before I go back and do the domain and range so I can actually see what's going on. And you can get your graph without looking at any of this. This will be a parabola shifted what direction? Close. Right 5. So we're going to go right 5, put a point, and I only want from 5 onwards. I only want half of my parabola. So I don't want to plug in any numbers this way. I only want to plug in numbers to the right. So can you give me a number bigger than 5? 6. All right, let's plug in 6. 6 minus 5, 1 squared, 1. Good. Let's do one more. Let's plug in 7. 7 minus 5, 2 squared, 4. Good. Okay, thank you for coming. I wanted that to be nice and easy. So do you see how we only got half of a parabola? That's the idea. You chopped it in half. All right. So what is the domain of that? Because it's not all reals. It would be from where to where? Yep. Good. 5 to infinity. And your range, you're sweeping downwards to upwards, would be 0 to infinity. Now, I'm not making you write it on here, but if I asked you for the domain and range of this inverse, what would you do with these? Swap them. Okay, good. I'm not going to make you, you can write it if you want to, but I'm not going to make you write that. You would just swap them. Because that point is included on here. It's on the graph. It's part of the party. If there was an asymptote, we would use a parenthesis because it would never touch that point. Does that make sense? Good. Now, to get your inverse graph, you don't need to look at any of this, really. You're just going to take these points and reverse them. So instead of 5, 0, you got 0, 5. Instead of 6, 1, you have 1, 6. And then instead of 7, 4, you have 4, 7. And if you want to dot in y equals x, you can. It's not a requirement. I just put it in there so you can see the reflection. So that's all you're doing. You're just taking half of the graph. You can only have half of it at a time because if you do the whole thing, it's going to fail your vertical line test. Now this one, I'm going to show you how to do the exact same thing, but we're going to choose the negative half. First thing, scribble out f of x, call it y. We're going to swap x and y. So just as a heads up, because I try to be really transparent with you. On the test, I have one that I force you to do the negative one, the negative half. And then I have one where I let you choose. And I assume everybody's going to choose the positive side. So trying to get you to do one of each. All right. So what would you do? We got 3 steps. What would you do first to, subtract 3. And then square root. Now you don't put plus and minus, you're choosing which one you want. So for this one, we just want the negative. We're going to do the negative version of this one. Again, I'm trying to show you how to do it both ways. You just pick one or the other is all you're doing. And then your last step is subtract 4. And you can put your inverse notation because it's going to be an inverse, a function. It'll be a function. It'll pass your vertical line. On the step where you would have put a plus and a minus, you just choose, do I want the plus or do I want the minus? On the step where we would have put plus minus, you just don't put plus minus, you just put one or the other. You're just making a choice which one. Yeah, that's it. On the step where you would have put plus minus, you just pick one or the other. Okay. So let's go ahead and graph this. We don't need any of this work to graph it. Using words like up, down, left, right, how did this shift? Yeah, left 4, up 3. Good. Now I can only plug in points to the left because we chose the negative half. So good, we're gonna plug in -5. We're right here at -4, so I'm gonna plug in -5. -5 plus 4. -1 squared is +1 plus 3 is 4. So we get -5, 4. And I didn't make a table, but if you want to like keep track of your points, you can make a table. So we did -4, -5. Let's do -6. -6 plus 4. -2 squared, 4 plus 3, 7. And it looks like half of a parabola. Again, you're just choosing a half. You're chopping it in half, picking which half you want. So domain, going left to right, it would be what to what? Yeah, -infinity up to -4, good. And then the range, you sweep downwards to upwards, so it would be 3 to infinity and beyond, 3 and beyond. And again, I didn't make you write it on here, but if I asked you for the domain and range of the inverse, you would just take those and switch them. That's all it is. You just take them and swap them around. And again, you don't need any of this. I keep covering it up because I feel like it honestly confuses people. You don't need any of this to graph your inverse. All you do is switch the points. So instead of -4, 3, 3, -4. Beautiful. Yeah, just switch them. What was the next one? -5, 4. So you got 4, -5. I'm not going to talk you through the rest of it. That's annoying. What would the last one be? 7, -6. Basically just counting little boxes at that point. And again, you don't have to dot in y equals x, but you can, and it shows you the reflection. I always think that one looks like, bless you, like angel wings or something. I always think this one looks like a fishtail. Does anybody see that? I don't know. That's what I always think of. I always like look at them like I'm looking at constellations, like, oh, what is this a picture of? So that's the long and short of that. You're going to choose one side or the other. Now, last little piece of vocabulary we're going to go over here, and this is being recorded, so you can watch the little end of it. Oh, no, don't want you to miss your butt. Oh, okay. Well, up to you. So last little piece of vocabulary, this goes quick, is a one-to-one function. What that means is the inverse is a function without a restriction. And what I mean by that is you don't have to cut the graph in half. All that work that we just did, if you have a one-to-one function, you don't have to do any of that. It means it's going to work out without you having to do anything. I'm getting to that. That's actually the next thing I'm going to write. It passes the horizontal line test, which is the exact same thing as the vertical line test, except a horizontal line. So it passes both vertical and horizontal line test. Now, if you don't have a graph to look at, and you're going to work it out algebraically, what it means is f of a equals f of b means that a equals b. And I realize that looks like gobbledygook right now, but I'm going to do a problem and then you'll understand it. So just trust the process for a second. So again, if it's one-to-one, it means you don't have to do that whole chop the graph in half thing. It means it's just going to work. Now, you all have an imagination, right? I want you to just imagine these graphs and think if they would pass the horizontal line test. So think about an absolute value. Would that pass a horizontal line test? No, it's going to go through twice. So no. A V shape, a horizontal line will go through twice. So no. How about linear? Yes, that would be good. Rational, oh, I've got my sticky note over here. Rational looks like this. No matter where you draw a horizontal line, do you see how it's only hitting once? Yes, that's going to pass. Cubic is a little wiggly thing. That passes. Quadratic is no. If you draw a horizontal line through, it's going to hit twice. And exactly, and that's the examples that we were just doing. And then square root looks like this, so that's a yes. Yippee. So what do you think about 12? Does that pass? No. Do you see how if you draw a horizontal line, it hits a whole bunch of times? Now, these ones, you don't have a graph to look at. So here's what you do. You're going to laugh because it's so basic. It looks like a really complicated thing, but it's really not. All you do is take the function and plug in a. So you're going to recopy this, but instead of an x, you're going to put an a equals, and then you're going to do the exact same thing except with a b. And then you're just going to kind of see what happens. And this is so silly, but what cancels out first? The unwinding is the important part. The fives cancel first. So you have this. But what if the graph is way more complicated than that? If getting a graph would be needlessly complicated, this is what you do. You're going to be okay. All right, what would cancel next? The fours, and again, the order in which things cancel is the important part. And then the threes cancel, you get A equals B, and so the answer is yes. If you end up with A equals B, then it's a yes. So let me show you what happens in this last one. Do the exact same thing. You're going to recopy the function, but plug in an A. And it's like, that's all we're doing? Yeah. Equals, and then do the exact same thing with B. Now, how would you handle this one? You would cross multiply. Thank you. So you get A squared equals B squared. And then to get rid of a squared, you would square root. But when you put a square root, you get plus or minus A equals plus or minus B. So does A necessarily equal B? No, A could equal negative B or B could equal negative A. So listen, and I'll even leave this on the recording. Why did we end up with a plus minus? It's because the original function had a squared or any even powers. So I'm trying to save you some work here. Are you listening to me? If there is an even power, the answer is no. So if you have a squared or something to the fourth or something to the sixth or something to the 32nd, if it's an even number, that answer is going to be no. Just trying to save you some work. Okay.